So when you are being asked for an absolute maximum or minimum on an interval, this is going to be your candidates test. And your candidates are going to be these endpoints and your critical points. So to get our critical points, we're going to find first derivative. So 3x squared minus 6x, set that equal to 0. We'll factor out 3x. And so our critical points are 0 and 2. Oh, and I got a new light bulb this weekend. Isn't this a lot better than that glare we had? It's like perfect now. All right, so I'm going to test my endpoints, so -2 and 4, and these critical points. And I like to put them on there in order. You can put them in whatever order you want, but I like them in numerical order. Oh, and Carson, I saw you typed in the chat. I'm just going to go over all of them. So we're just going to do everything. Now these are going to get plugged into the original function. So if we plug in -2, cubed, that's going to be -8. And then squared would be 4 times 3 would be 12. So -12. And then plus 12. So that'll be -8. And if we plug in 0, we're going to get 12. And +2 is going to give us 8 minus 12 plus 12, so 8. And then 4 cubed is 64. 4 squared would be 16 times 3 would be 48. And then plus 12, so gosh, what is that? Top of my head. I'm just going to type that in the calculator so I don't mess it up in my head. I could work it out, but I don't want you guys to like just sit there watching me do this by hand. 28. All right, so are they asking for absolute maximum? Now, sometimes they ask for the maximum, which would be 28, and sometimes they ask for where it happened, which would be 4. So just be careful. 28 is the maximum, 4 is its location. And they said occurs at x equals, and so that would be 4. So A for that one. All right, number 2, the graph of f prime, the derivative. All right, so we have the derivative graph, which describes the relative extrema on the open interval a to b. Okay, these are our critical points. And at this location, we would have a relative minimum. And that is because our derivative changes from negative to positive. So that would be below to above. And then this is also going to be a relative minimum because we have a change below to above. And then this one would be the location of a relative maximum. So we have 2 relative minimums and 1 relative maximum. So that is choice A. All right, so for this one, again, we're given the derivative graph. That is shown, which of the following statements must be true? Well, let's go through them. Relative minimum at -3. Well, same as the question we were just doing, that will be where we have a relative minimum because the derivative changes from negative to positive there. So this one is good. Point of inflection. Let me get out my little cheat sheet. I put this on a stick-it note so I could pull this out whenever we need it. Point of inflection is where f changes from concave up to concave down or vice versa. Now, this is the graph that we're looking at, f prime. So that would be where this graph changes increasing to decreasing or vice versa. So that's what we're looking for, is a change increasing to decreasing or decreasing to increasing, which happens right there. So point of inflection at -2, well, no, the point of inflection would be at 0. So that one is false. And then the last one, the graph of f is concave down from 0 to 4. So again, looking at this, concave down would be where the graph we are looking at is decreasing. So again, you're answering questions about a graph you're not looking at. You're looking at the derivative graph. But f would be concave down where this graph is decreasing. So this graph is decreasing from 0 all the way to the, what is that, 4? From 0 to 4, which is what this says, so that one's good too. So we want 1 and 3, which was E. Right, number 4. First derivative of a function is defined by this, and I can already tell I'm going to need a calculator for this because I've got all these crazy decimals. This is our interval 0 to 2. On what intervals is f increasing? Now f is increasing where the derivative is positive or above 0. So since they gave us the derivative, and this is the first derivative function, we want to know where this graph is above 0, so above sea level. All right, so I am going to go to y equals and type in that function, that derivative function. So sine of x cubed minus x. And then I'm going to go to window and make my window 0 to 2. Oh, I must have been doing something really strange in here before. Let me just make that negative 5 to 5. We'll see if that's good enough. All right, so again, we want where this graph is above 0. Now that looks like about from 1 until like here-ish. That's where we're above sea level. So from 1 until right there, I need my calculator to give me that value. So I'm going to go to calculate, second trace. I want a 0. And if this is 1 and the end of the interval is 2, I know this is somewhere in between 1 and 2. So for left bound, I'm going to hit 1, enter. For right bound, I'm going to do 2, enter. And for guess, I'm going to put 1.5, enter. And it will come up. So 1.690. So this graph is above the x-axis from 1 until 1.690. So that would be B. They round it up. I like to truncate, they round, but your answer is B. All right, number 5. At which of the 5 points, those are our choices there, are the first and second derivative both negative? All right, if the first derivative is negative, that means the graph should be decreasing. And if the second derivative is negative, that means the graph should be concave down. So we want a value where we are decreasing and concave down, and that's happening at B. The graph is going downwards and it's like bending downwards like this. So that one is B. All right, for 6, we've got these values in the table. Let f be a polynomial function. F prime is given for selected values. So this is the derivative. Also, they said that it's a polynomial. If it's a polynomial, what do we know about it?
It's continuous, right?
Yeah, good. All polynomials are continuous, and they're also all what? They're all not only continuous, but also what?
Differentiable.
Yeah, perfect. So we won't have any issues in this graph. There aren't any asymptotes, there aren't any holes, there aren't any breaks, there aren't any emotional problems. Everything is good, right? So f prime values are given in the table. Which of the following must be true on that interval -2 to 6? So you can read through all of these. I'm going to go through the one that is the correct answer. We have to have at least 2 points of inflection. I'm a real visual person, and I would probably just go ahead and draw these points and connect them. If we've got -2, 3, 0, 1, 3, 4, 5, 7, and then 6, 5. So if you connect those like a polynomial, and again, this isn't like exactly perfect because we don't know what's happening in between. Like this graph could go all the way up here and come back down. You know, we don't know specifically what's happening. But at the very least, it is turning around 2 times. And if f prime changes from decreasing to increasing or increasing to decreasing, then we know we're going to have a point of inflection. So we have to have at least 2. You could have more. Like I said, I don't know what the graph is doing in between these points, but we're going to have at least 2. All right, 7. F of x is given by this thing. We want to know where the graph is concave down. That means I'm going to need a second derivative. So first we'll get the first derivative. And what rule will we need to work through this? What rule are we going to need?
Product.
Yeah, good. That's going to be product rule. So I kind of parenthesed it off here. 2x is going to be the first thing. So first, and then derivative of the second is itself, plus the second thing, and then derivative of the first is 2. So just to like clean that up a little bit, 2x e to the x plus 2e to the x. So our second derivative, for this first part, that's going to be another product rule. So first derivative of the second plus second derivative of the first. That's another product rule for this piece of it. Plus, and then derivative of 2e to the x just is 2e to the x. We're going to want to set this equal to 0 to find inflection points, and I'm going to need to make a number line to see where I'm concave down. Just cleaning this up a bit though, this is 2x e to the x plus, we have 2e to the x and 2e to the x, so 4e to the x. And then factoring that, we can take out a 2, and we can also take out an e to the x. So that would leave us with x plus 2. And now setting each of these equal to 0, this is never going to be 0. E to the x looks like this, and you have that asymptote there, so it's never going to touch 0. So we don't get any inflection points out of this. All we get for this one is -2. And if you make a number line for that, and pick test values, you're going to have negative until you get to -2 and then positive. Again, I didn't bother with this one. That is positive all the time. That graph is always above sea level, no matter what you plug in. So you would have a number line that just had pluses the whole way across. So that's why I didn't bother with that one. But we're going to be concave down for this section and then concave up for this section. So I forget at this point which they asked for. Concave down, that would be all the numbers smaller than -2. So that is A. That one was a lot of work for a multiple choice question, but sometimes they're like that, so you got to get through it. All right, number 8. F is a function that is continuous, so we're given that from 2 to 4. F of 2 is 10 and f of 4 is 20. Which of the following is guaranteed by the intermediate value theorem? Intermediate value theorem, as long as your function is continuous, means that you have values in between these other two. So in between 10 and 20. So that means we are guaranteed a value in between 10 and 20 on this interval 2 to 4. So I think it was, what was this one? I think they made it 13. Yeah, function equals 13 at least one time on that interval, and 13 is between 10 and 20. So that's what that is going to have to be. The problem with B, because you're probably like 15 is also in between 10 and 20. They said specifically that happens at 3. We don't know that. We know 15 is going to happen at least once in there, but we don't know that it happens specifically at 3. It could happen anywhere on the interval. It could happen at 2.5 or 2.1 or 3.9. You know, we don't know that it's necessarily at 3. All right, number 9. Let f be a function given by this. What are all values of c that satisfy mean value theorem? So when I see mean value theorem, mean means average. So we're going to do an average rate of change equals instantaneous rate of change. And average rate of change is just slope. So on the interval 0 to 3, I need to get my 2 points and do slope. So if I plug in 0, I just get 0. If I plug in 3 cubed is 27. 3 squared is 9 times 3, 27. So that's also 0. So a lot of zeros in this. So our slope is just going to be 0, isn't it? Slope would be 0 minus 0 over 3 minus 0. Anything with a numerator of 0 is just going to be 0. Okay. And so we're going to find our instantaneous rate of change, our derivative, and set it equal to 0. That one was kind of weird. It came out to 0. So actually, this is Rolle's theorem. Rolle's theorem is specifically when that rate of change is 0. So our derivative will be 3x squared minus 6x. I'm going to set that equal to 0. Factor out 3x. And I get 0 and I get 2. Now it cannot be 0. Why not? How come I have to get rid of 0? And it's tricky because that's a choice.
Because it's on 0 to 3.
Yeah, 0 is one of the, it's on 0 to 3. So 0 is one of the endpoints, and you can't have that at an endpoint. So only 2 is our answer, so B. All right, and last one. Function f is continuous and differentiable. We're given f of -2 is -5 and f of 1 is 4. So those are 2 points that we've got here. Which of the following statements could be false? All right, so these 2 points we've got are -2, 5, and 1, 4. It helps me if I can see them as coordinate points. So let us read through our choices here and see what we've got. So there exists C somewhere in this interval where f of C equals 0. Is that an f prime of C or is that f of C? F of C equals 0, and I think I wrote this wrong. This should be -5. So if we've got a point at -5 and then at 4, and our function is continuous, 0 is going to have to be in between those. So that one's going to have to be true all the time. And we're looking for one that could be false. So it cannot be that one. All right, letter B, there exists a C somewhere on the interval where the derivative is 0. Now that would be mean value theorem. So we need to do the slope of these 2 points and see if it comes out to be 0. So that'll be 4 plus 5 over 1 plus 3. So what is that, 9/4? Or no, 1 plus 2. Gosh, I can't read today. So 9/3, which would be 3, which did not come out to be 0. So that one could be false. I mean, it might be true, but probably not. So that one's going to be our answer. And just to look through the others, there exists a value on the interval such that we get an output of 3. Well, 3 would be in between -5 and 4, so that would have to be true because the function's continuous. This one, there would exist a C where the derivative would be 3. Well, slope of those points was 3, so that's mean value theorem, so that would have to be true. And then this one, there exists a C that would be bigger than all of the other values. That just means that there is a maximum. That's your extreme value theorem, so that one would also have to be true. But we were looking for the one that was false, so B is our answer.